Welcome, everybody. Thanks for attending today. My name is Jennifer Griffith, and I work at NMOA, which is the Northeast Waste Management Officials Association. And just want to confirm with Liz, can you see my screen, the website?
I can.
Okay. So I just have this up so that people can read for themselves about what NMOA is. We're an interstate association. 6 New England states, New York and New Jersey, belong to NMOA. And the wayside cleanup programs in those states belong to NMOA. And one of the main priorities for those programs is training for state staff and information sharing. And another priority is PFAS. NMOA's been working on PFAS and holding interstate conversations since about 2016 on PFAS. So our states have decided that it's great to share information widely and get everybody on the same page. So we open up our webinars and events to everybody. So welcome. And let's see, I have the website up here because I want to show people after the webinar today, eventually in a few days or a week, the presentations will be posted on the NMOA website for your reference if you want. And I'll just show people how to navigate there because there's also a lot of other good stuff. So NMOA.org, that's our homepage. Then on the left here is a wayside cleanup button. And when you get to wayside cleanup, you click on events. Here's all the different events that are coming up. It's got the one farthest down in the future is at the top, and so then you need to scroll down. Eventually, you get to where it's past events. And then this is where different presentations will be posted. Here's some of the other webinars we've done. And we also, NMOA, the wayside cleanup programs, do things other than PFAS as well. So if you're interested, we did some webinars on PCBs and on vapor intrusion not too long ago. So there are those presentations accessible as well. Pre-pandemic, we also used to hold in-person workshops that lasted a whole day. And those presentations from those are also here on the website. So there's a great wealth of information here for folks, particularly when they work in wayside cleanup. So I think, because there are so many people attending today, which is great, we are not going to be able to do questions, have people unmute themselves and ask. So you're going to need to type questions in. You can type questions in at any point. You don't have to wait until the presentation is over to type your questions in. So we're going to first have Liz present, and then we'll ask some questions about her presentation, and then we'll have the second presentation, and then we'll end up with questions. Again, a question period, and I will be reading questions that come in via typing. There's a question feature in your GoToWebinar control panel. So I think with that is everything I need to do. So I am going to introduce the first presenter and give her control here. Okay, so Liz Hariman is an engineer and also the Deputy Director of the Toxics Use Reduction Institute, which is also known as TURI, at the University of Massachusetts in Lowell. She has 30 years of providing technical research and support services to Massachusetts companies and communities to reduce the use of toxic chemicals and identify safer alternatives. She's worked with others at TURI as TURI's Science Advisory Board has evaluated PFAS over the past several years. Liz is a registered professional engineer and also holds her bachelor's and master's degrees in civil engineering from Cornell University, and also has a master's degree in hazardous materials management from Tufts University. So with that, take it away, Liz.
Thanks, Jennifer. And you can see my screen and hear me okay?
Yes, I can.
All right, super. Well, thank you, and thanks to Numoa for hosting these webinars. They've been really informative. I really appreciate it. So a lot of you are working on cleaning up or protecting us from environmental contamination. And every day, more PFAS are added to the environmental and human health burden. So we need to find a way to turn off the tap, so to speak, of those pollutants. And that doesn't just mean banning a particular chemical that we know is harmful, like PFAS or PFOA. That often encourages a move to similar chemicals that are not quite as the same, but it just introduces regrettable substitutes. So how can we approach this to understand why we use the class of chemicals in the first place? And as we look to move away from them, how can we avoid regrettable substitutes? So I'm going to give you a bit of context about the toxics use reduction TUR approach, so you know where I'm coming from. And then we'll talk about a range of PFAS and some of the many uses, and some strategies for avoiding regrettable substitutes. And as we try to reduce the use, and we'll then walk through a couple of examples. And then after that, you're going to get a deep dive from Mike Shade into one important consumer use on food packaging. So the Massachusetts Toxics Use Reduction Act was passed in 1989 with a goal to help Massachusetts companies and communities reduce their use of toxic chemicals, and in doing so, to improve business competitive advantage by being more efficient and safer. The law doesn't ban the use of chemicals. Manufacturers have to report their chemical use and go through a planning process to identify TUR opportunities and options, but they don't have to implement those. That's up to them. And they also pay a fee to the state, which goes to support a team of partner agencies that work closely together to implement the program and help facilitate that transition. So that's Mass DEP, the regulatory arm. The Office of Technical Assistance does direct on-site technical assistance to companies, and they're actually currently working with EPA and DEP and others to identify sources of PFAS from Massachusetts manufacturers. And at TURI, at UMass Lowell, we provide a variety of support, training, grants, research, policy, I guess, and our PFAS focus for the last several years has been working with our science advisory board to evaluate this kind of vast world of chemicals. And the SAB has recommended a large category of PFAS be added to the TURA chemical list. And so TURI's prepared a policy analysis with input from our stakeholder advisory committee. And then that proposal's been presented to our administrative council, which will at some point make a decision. So just one more slide about sort of where toxics use reduction and prevention fit into this wider world of dealing with PFAS. You know, borrowed the occupational health hierarchy and the public health prevention levels just to give you some context, but we sort of missed the boat on prevention when these chemicals were introduced. And so we're now heavily focused on mitigation, dealing with the contamination that's already in the environment and in biota and in people. So primary prevention, the top of the hierarchy, is where we turn off that tap and stop adding constantly to the environmental load. So TUR preferentially eliminates the hazard, being careful about regrettable substitutes. And then when that is impossible, we can reduce the potential for exposure and emissions to the environment. So I'm going to assume that you're all already pretty familiar with PFAS, and just note that the unique and useful functional properties, because PFAS have very unique and very useful functional properties that we're going to go over, as well as their persistence, those things come from the strong carbon-fluorine bond and the alkyl chains that are surrounded by the bulky fluorine atoms. That tail is excellent at repelling oil and water. So you're going to see a lot of uses that take advantage of that. There are nearly, it's like an infinite number of ways to combine these chemicals. You can add other functional groups, you can insert oxygens and other atoms into the chains, but they're all defined by that carbon-fluorine bond and mostly by carbon chains or ring structures. So there are thousands of compounds. So what does that PFAS class look like? What kind of chemicals are actually being used in manufacturing and products? So you're going to find PFAS used in manufacturing and processing as raw materials, intermediates, and byproducts, waste out of that manufacturing process. They're also incorporated into commercial products, into industrial and consumer products. And then those eventually become wastes or emissions during or after use. You also find them as metabolites and degradation products. So there are many complex chemicals used as raw materials and in products, and we refer to those as precursors. So when they get into the environment or biota, like humans, they gradually break down into those terminal degradation products that are very persistent and never break down, and are the ones that we're now trying to clean up, like for example in groundwater. So there are many, many precursors, but a much more limited set of terminal degradation products. So today, because we're talking about uses and alternatives, we're focused on those commercial products. So a couple of quick examples. On the left is a non-polymeric example. So that's a fluoropolymer alcohol on the top used as a raw material. And then you produce a much more complex surfactant. This one used in AFFF, or aqueous film forming foam, used in firefighting. I think Numoa has a webinar coming up on that. On the right is a polymeric product example. So raw materials include PFAA, and the perfluoroalkyl acid, in this case a PFHXS, and that the product that you're making there is a fluoropolymer like PTFE or a side chain polymer, which are shown down in the commercial product part. But in both cases, the non-polymer and polymer examples, eventually they will break down into the terminal degradation products at the bottom. So the example is PFHXS, which is shown down on the bottom. And I assume that those are the chemicals that most people on the call are familiar with in terms of environmental contamination. So what are some of the uses? These are examples primarily of consumer uses, and we're gonna look at them from a functional use perspective. So one very important functional use is that oil and water repellency. So you're going to get that. Actually, let me see if I can use my pointer. Yeah, laser pointer. Can you see that laser pointer? I think you can.
I can.
So, oh, super. So for an example of oil and water and stain repellency is stain-resistant carpet. Food packaging, which Mike's going to talk about later. Furnishings, we use it on upholstery. In outdoor gear and outdoor clothing, it's very important for water repellency. It's also used on leather and footwear and other products, again, mostly for water and stain repellency. Car seats, anyone with children knows that the stain repellency there can be important. So we also have, I seem to have lost my picture. Hang on a second. So we also have uses that are around lubricants and emulsifiers. So those are used in cosmetics and also in adhesives and sealants. We have surfactants. Again, very important surfactants. They provide low surface tension. Those are used in some carpet cleaning products, and that's certainly the use in the firefighting foams. They're also film formers, and so the powerful surfactants do quite a job there. I'm going to try to get rid of my picture here. Whoops. So some industrial uses. There are way too many to describe today, but I wanted to highlight just a few that may help you figure out where some of the environmental contaminants that you're dealing with might be coming from. So there are also some references at the end of this presentation. There's an excellent paper by Gluke et al. And there's also some information from the industry trade group or the Fluoropolymer Partnership that are good resources for the fluoropolymers in particular. So we're going to talk about polymers first. Polymers and resins, they incorporate fluorine into a polymer that provides great chemical resistance, thermal stability, and strength. So some of those are fluoropolymers like PTFE or the brand name Teflon should be familiar. We use those as coatings on cookware and many other things like medical devices. Fluoropolymers are used in wire and cable and tubing, gaskets, separation membranes on flexible roofs, all sorts of other uses. And the PFAS are not just in the fluoropolymers, but they're also used as fluorinated processing aids for other resins. That helps with smooth extrusion. And we also have a case in Massachusetts where the Anvil pesticide used to spray for triple E was found to contain PFAS, and they determined that that was from a fluorination process for a non-fluorinated polymer container. So there are many different ways you can add the fluorine into the polymer in order to provide the higher performance properties. They're also used in fuel cell membranes like proton exchange membranes. Nafion is a brand name that's used in many of those. And that's where you have a PTFE backbone, but then you have other fluorinated ether groups off from that. And so there's, again, an almost infinite number of possible uses for the fluoropolymers. Industrial uses that are not polymer, non-polymer uses. In metal finishing, you may be familiar with the surfactants used as fume suppressants in hexavalent chromium baths. We're going to talk about those in a minute. And they're also, fluorinated chemicals are also used as solvents. One of the common substitutes for TCE is 1,2-trans-dichloroethylene, and that is often provided as a mixture with hydrofluoroethers or other fluorinated chemicals. They're used as solvents, blowing agents, and refrigerants. Some of the other chemicals are hydrofluoroolefins and hydrofluorocarbons. And they're also used in lots of different situations as surfactants and lubricants and in coatings. One of the issues with some of the uses like surfactants is that the percent may be very low, and so they don't show up on a safety data sheet, which means that we may not really know that they're in there unless we ask our supply chain. So that's just a brief overview of some, to give you an idea of what the uses are. Now, how do we transition away from PFAS? What does that look like? Well, we want to accomplish it without regrettable substitutes. So we're going to do an alternatives assessment. And right now, I'm just going to pull out a few steps out of that process. There are lots of other references that you can go to. For example, the IC2, Interstate Chemical Clearinghouse, OECD Toolbox, California Safer Consumer Products. There's a bunch of different TUR planning is one, so a bunch of different alternatives analysis or alternatives assessment framework, but we're just going to pick out a few steps here that are important. So we're going to look closely at the use and the function and ask, is it necessary? Is it necessary in all applications maybe, or just high performance ones? Do we really need the performance that this particular chemical is providing? There's been a large body of work developed, particularly in Europe, around the essential uses concept. So there we're thinking we would only use something like a PFAS in essential uses for which there are no safer alternatives. So are there safer alternatives, particularly for critical uses? And we're going to think here about the class approach, which you may have already heard that excellent webinar that Numoa did. So does it make sense to substitute a similar but less studied chemical with a similar structure? Probably not. We're going to look upstream and downstream and think broadly about the function, not just about chemical substitution. And if use is essential and no safer alternatives are available, what do we do then? Are there ways to use less and limit exposure, maybe avoid emitting it to the environment where it's never going to go away, and do those things while you get started on R&D? So just kind of visualize that, and then we're going to do a couple of examples. So we're going to think about the essential use concept and what's the actual function of the chemical, and is that function or the product necessary? Is it for all applications or just high performance one? We have a term called fit for purpose. So we may not need to use the high functionality of a fluorinated chemical. It just happens to be the one we use for our full range of products. So let's use the least toxic chemical we can for a particular need. We're going to think upstream. When thinking about substitution, we're not just going to think about the chemical substitution, but can we change the material or approach the need in a different way? And in looking for safer alternatives, we're going to keep that chemical class approach in mind by trying not to substitute something similar but unregulated. We're going to evaluate these options and using an alternatives assessment, remembering that all chemicals used will eventually become a waste or emission. So I tried to pick one example that you might not have thought as much about before. So PFAS are widely used in waxes and polishes for a lot of different applications, cars, floors, and skis. So the ski wax, of course, wears off directly into the environment, and the ski waxers have been found to have high exposure when they remove and lay down the wax. So what is our function? The function is in order to glide, you need low friction and you want a water-resistant surface that keeps the snow and ice from building up and gives you a nice layer between the snow and your ski. But you also have to have a wax that's able to kind of grab on occasion like a kick wax. So there are very complex things going on under your ski. Is that essential? Well, it depends on whether you're a competitive skier or not. And this brings up an important issue in the whole essential use discussion, which is who decides. But it may be that some of this performance is required for a particular competitive ski situation and not for recreational, for example. So what are the alternatives? One way is to look at what we used before we had fluorowaxes. We use pine pitch and hydrocarbon paraffins. So sometimes going back to what we used before and trying to find higher performing ways of using those chemicals is one approach. Many companies have gone from C8 to C6 waxes, still fluorinated. And there we have a concern, of course, that is the same chemical class and will be a regrettable substitute. Some companies have come up with novel fluoro-free waxes. Swix Pro is one example. And that also provides a good example of often when we substitute something for a toxic chemical, the toxic chemical is actually works sort of universally across a wide range of parameters, whereas when we go to find a safer substitute, we actually have to tailor it a bit more to the specific need. So the Swix Pro system has many different products for many different weather and snow conditions. Another way to look at it is there another way to achieve that function? Is there a different ski material that doesn't need waxing, or a different surface topography? If you do cross-country Nordic skiing, you might have waxless skis, which have scales under the kick zone. So whatever you go for, we want to end up doing a comprehensive alternatives assessment on whatever that material is, whatever the replacement wax is. And sometimes this information is hard to find. Particularly on safety data sheets, either when the percents are low or the substances aren't already recognized as being hazardous, or they're called confidential business, it can be hard to find that information. Another example, industrial example, is PFAS used as fume and mist suppressants in hexavalent chromium plating and in chromic acid anodizing operations. So here we're trying to protect the workers from the mists and fumes that come off those tanks. So our function is as a surfactant. It lowers the surface tension. Particularly for chrome plating, you have bubbles coming off the anode and cathode, and they carry that hex chrome up into the breathing space of the worker. So you want something that will lower the surface tension and keep those bubbles from being large and rising. And you also want something that is able to be stable in a pretty harsh environment. So is that essential? Well, as long as we're still doing hex chrome plating, it's essential to protect employees. Will the performance criteria vary somewhat? It will vary somewhat with the application. So a chromic acid anodizing tank may not need the same protection as a hard chrome plating tank, for example. And what kinds of alternatives will we look at? Well, the one that Turi's been looking at for a while is non-hex chrome metal finishing. So if we aren't using hexavalent chromium in the metal finishing shop, then we don't have to worry about the exposure of the employees. After that, we've also had a company who put in a closed system, and therefore the workers aren't exposed and they didn't need to add the fume suppressants. There are other drop-in alternatives. At the moment, those are primarily C6 fluorinated surfactants. So again, here you have the chemical class issue. But there are also some non-fluorinated surfactants. They have a hard time meeting some of the performance requirements and being stable enough to last well in the baths. So that's a need for continued R&D as long as we're doing hexavalent chromium metal finishing. One more example is durable water repellent textiles. So you may be familiar with this one from your garments or your furniture or your tent. The function here is water and oil repellency. So question, is it essential? Well, it's used in a whole lot of different things, from firefighter turnout gear to demanding outdoor applications to, perhaps children's fleece. So there are all sorts of wide range of uses. And those applications do not all have the same performance needs, even though we may be using some of the same fluorinated chemistries to deal with them. So it's very important here to try to look and see what is my real need, what is my performance that I really require. If the product can be washed easily, maybe you don't need stain resistance. So what are some of the alternatives? And again, here we really want to look at that fit for purpose where we have so many different uses and different kinds of applications. So what are some of the alternatives you might look at? Well, one, when they're looking at carpets, they've been looking at alternative ways of weaving and alternatives to the fiber so that you don't have to add a coating onto it. Some of the other coatings that have been introduced are either shorter chain fluorinated, which would be a regrettable substitution, or there are a lot of hydrocarbons, be those paraffins, melamine, acrylics, variety of things, other waxes. Silicones or siloxanes are very popular. Polyurethane is used in a lot of the outdoor gear. There are also some emerging solutions that are based on nanomaterials and dendrimers. This is one area where it's particularly challenging to find out what that information is about the chemistry. There's a lot of proprietary information. There's a great European Commission report that's out, and the reference is at the end. But you can also look at the ChemSec marketplace or green screen certified products and find things that have been screened by others for their hazard. But you certainly want to try to find out what's in something before you just adopt it. So these are some selected resources, some around the essential uses or around uses in general, and also around some of the chemical class concepts, and some, I also put the link to Tori's policy analysis and a recent report on textiles if you're interested in the durable water repellency. So I think that's what I've got, Jennifer. I'm going to hand it back to you, or you can take it back.
We'll leave it here, your last slide.
Okay.
So excellent, Liz, that was really great. And as a cross-country skier, I really appreciate that example of the wax. So I'm going to ask a question to you, which is the waxless skis, are they coated? Is the manufacturer skis using?
So the waxless Nordic skis are you don't have to wax them, right? I confess I have ancient skis and mine have to be waxed, but I have used the waxless ones, and some people still will put glide wax on the front and the back.
Right, but I was wondering the manufacturer of those wax is PFAS used in the manufacture of the surface?
I don't know. Good question to ask. I don't know what that material is on the bottom of the waxless skis.
Okay, so a bunch of questions now. Is hexavalent chromium the only metal finishing process that uses a PFAS surfactant, or are there other metal finishing processes that people should be concerned about?
So there are other metal finishing processes that use PFAS in the bath. I believe that the Hex Chrome is the only one that uses it as that fume suppressant. but it's definitely used in some other metal finishing baths. I think I mentioned a couple of them on that industrial slide. We can get more information if somebody's particularly interested in that.
Right. Okay. One, I don't know these acronyms myself, but hopefully you do. Are HPDs and EPDs useful for locating PFAS in products?
Say those acronyms again.
HP and EPD. Maybe the person type that in, spell it out.
Yeah, so it sounds like they're trying to figure out whether, like doing testing to figure out, analytical testing to see whether there are PFAS in the product?
Well, I think they're asking whether you can find information about whether.
Oh, I got it. HPDs and EPDs. Yes.
Health product declaration and environmental product declaration. Would
Yes,
those be
yep,
resources?
okay. Got it. I'm sorry, I misunderstood your acronym. Yes, they can be if they go down to a low enough ppm on the HPD or EPD. And I think that in another week, I put this link on the previous slide as well. I think that in another week, the Green Science Policy Institute is coming out with a report on building materials, which is where I'm mostly familiar with finding the HPDs and the EPDs. And so I bet they have mined those for that information. And that's the Green Science Policy Institute upcoming report. So I would watch for that. And I have found that information on I'm trying to put in a new counter in my kitchen, and the penetrating sealants, for the most part, are all fluorinated. And so if you can find an HPD, it will tell you that.
Okay. We'll take a few more here. So are there alternatives to the fluorination of those HPDE, the pesticide containers that you mentioned, which those type of containers only contain pesticides? They're used for other purposes as well. Maybe you could talk a little bit more about that. And then are there alternatives to fluorination of those containers?
Yeah, so we don't really know how many different types of products get that fluorination. I think it particularly helps with the chemical resistance, and that may be why they have chosen it for the pesticide container. We asked the folks in our plastics engineering department at UMass Lowell, and they were familiar with the process and said that it did, it provided some of the same properties you get from a fluorinated polymer. But I think there's a lot of science in the resins in general, and I can't imagine that there isn't another way to make a durable container for anything without a fluoropolymer. So if you have specific questions, we can follow up. I know that Mark Smith at Mass DEP has also done a lot of research into that, but we can follow up with our plastics engineering folks if you have a particular question.
Okay. Do you have? Yeah, there's an echo when I talk. I don't know if the speaker on somewhere, but I've got all mine mute.
I don't hear the echo.
Any thoughts on the volume of, the amount of actually used in manufacturing, and whether those industrial sources are going to be used enough to exceed the threshold for TURI?
Oh, that's a good question, and we're guessing that most uses will probably not. Either that the percent in the product is below the de minimis required to count it toward a threshold, or that that they just won't use enough. Of course, our council hasn't yet set a threshold either. In case they decide to make it a higher hazard substance and set a lower threshold, that'll be different. One of the other things is that within that large category that was recommended by the Science Advisory Board, that includes polymers. So if someone's processing PTFE, then they would be more likely to trip that threshold, as opposed to someone who's using very small amounts of surfactant in a product or in their Hex Chrome bath.
Okay. So in their past experience, there are a number of fluorinated compounds in semiconductor industry. Is that still the case?
Yes, that's definitely still the case, and I didn't really go there. Those uses are kind of specialized. There's a big concern around going to 5G and what kinds of infrastructure that's going to require, and the fluorochemical and fluoropolymer industry feels like they have good solutions for all of that. But if we're looking at putting these units, everywhere and close together, then that could be a really large demand for that chemistry, and maybe that's not such a great decision to make. So, but they're definitely used in a whole variety of coatings and other applications in electronics.
Okay, one more. I'm the system that's to eliminate the use of suppressants in the Hex Chrome plating.
So say that again?
Can you talk more about the for Hex Chrome?
The alternatives to Hex Chrome. I'm sorry, you're cutting out a little bit, Jennifer.
Yeah, the closed
loop.
Yeah.
So, or closed system. So we had a company Columbia Manufacturing in Westfield, Mass, that made their Hex Chrome process closed, and therefore, the potential for releases was very, very, very small. And I think we have a.
Okay, I'm following up with the suggestions people have typed in about the echo. Sorry about that. So Liz is muted right now, but let's see. Oh, there was one more question that came in, which is about have you looked at, so don't start talking yet, Liz, till I unmute you. Have you looked at some other common consumer products like dryer sheets and fast food? I guess we're going to hear more about fast food from Mike here, but have you looked at more of the consumer products? And now I'll unmute Liz. Okay. Oh, now she's self-muted. Ah, shoot. Now we can't get her back.
I'm unmuted now.
Okay.
So yes, Mike's going to take over and talk about the food packaging, which is a huge issue and huge area. I don't believe that they are in dryer sheets. One thing is, as I trolled the internet looking for a particular piece of information the other day, I did notice that someone was advertising the use of a fluorinated coating on surgical gowns and masks. And I'm like, no. So I have no idea whether that's one marketing person's wishful thinking or whether they might in fact be used as a water repellent finish on some surgical masks. But I'm not aware that they are used in dryer sheets.
Okay. Thank you so much, Liz. Great. Transition now. Sure. So our next presenter is Mike Shade. He's the campaign director for Mind the Store, and I'm just got to make him the presenter here. A program that challenges the nation's leading retailers to transform the marketplace away from hazardous chemicals and towards safer alternatives. For the previous 9 years, Mike was the markets campaign coordinator with the Center for Health, Environment, and Justice, CHEJ, which is a national organization, environmental health organization, where he led national campaigns to phase out PVC plastics, phthalates, and bisphenol A, BPA, and dioxin in consumer products and packaging. Prior to CHEJ, he was the director of the Buffalo Office of Citizens Environmental Coalition, CEC, which which is a New York statewide grassroots environmental health organization. Mike has his BS in environmental studies from the University of Buffalo, or at Buffalo. And with that, take it away, Mike.
Great, thank you so much. Can you guys hear me okay?
Yes, I can hear and I can see your slides.
Terrific. Well, thanks so much. I'm really excited to be here today. As you noted in the intro, I got my work started on environmental health and toxics issues about 20 years ago when I started working on working with community-based groups up in the Buffalo, Niagara region, working to get Superfund sites and brownfields cleaned up. And in that work, after a number of years, I really got passionate about thinking about how can we not only make those communities whole and get them cleaned up, but also how can we prevent these problems from occurring in the first place. And that's really been the focus of my work over the last 15 years or so since I left Buffalo. And so I'm going to talk about our work with the Mind the Store campaign to engage retailers to use their market power and influence to drive harmful chemicals, particularly PFAS today, out of products and packaging. And I'll talk both about some of our activities with the campaign, ways in which we've worked to drive change in the retail sector, but also talk about examples of policies that have been developed by top retailers, as well as talking about resources that can assist businesses in identifying and transitioning to safer alternatives, particularly, and I'm going to focus today on food packaging as a case study. So we launched our campaign about 8 years ago to call on the nation's top retailers, at a time when, unfortunately, the federal government historically has not done as good of a job as it could or should to protect consumers and communities and workers from hazardous chemicals. We think that retailers can really fill a critical federal regulatory void by leveraging their market power and influence to drive classes of chemicals out of products, packaging, and global supply chains, and developing more systemic solutions to avoid regrettable substitution, and also helped catalyze demand and the market for innovative, safer alternatives. So in thinking about that, in PFAS, food packaging, sadly, has been an area where these chemicals have been prevalent for a number of years. And we're concerned about their entire life cycle, which I'm sure we've heard on some previous webinars that NUMOA has hosted. When we think about the issue of PFAS in food packaging and food contact materials, it's its entire life cycle that we're concerned about. If you look at the communities where PFAS chemicals are manufactured for food packaging, like down in the South, communities have actually suffered from drinking water and groundwater contamination downstream of the Daikin chemical plant, which is the only chemical facility in the US that makes PFAS chemicals for food packaging. There are communities whose drinking water have been contaminated, and residents believe their health have been harmed as a result of drinking contaminated water. Also concerns about land spreading of PFAS contaminated sludge in those communities as well. So we're concerned about the production. We're also concerned about its use, because when these chemicals are added to food packaging, they're used for their grease and water resistance. We're concerned about the fact that these chemicals can migrate out of the food. They can then make their way into our bodies when we consume the foods. Especially concerned for young children who tend to love to eat at places like McDonald's and Burger King, where these chemicals seem to be prevalent. And also, of course, we're concerned about their disposal. If you think about it, you buy a burger, it may be wrapped in packaging with PFAS, you throw it out, or maybe you try to recycle it or compost it. Packaging is used once, but the chemicals can literally last forever in the environment, persisting for hundreds, maybe even thousands of years. Packaging may be disposed of in a landfill. There's concern that the chemicals can migrate out and contaminate water supplies, groundwater, drinking water, near landfills. When the chemicals are incinerated, when the food packaging is incinerated, I think there's a lot of questions about how those chemicals may travel in the environment, travel along directions. And then, of course, a lot of the food packaging today is marketed as biodegradable or compostable. And when that food packaging is composted, the concern, a significant concern, is also that the chemicals can migrate out, they can contaminate the compost, and then the compost is used to grow crops. And again, then we're exposed. So this life cycle is quite problematic, and that's a key reason why we have been working to drive these chemicals out of food packaging. So in talking about some of our work, one of the tools that we've deployed in our campaign over the last 5 years has been to put out an annual report card that benchmarks and surveys top retailers on how they're managing chemicals of high concern in their products and packaging. This is a screenshot of our website for our annual Who's Minding the Store Retailer Report Card. We just published our 5th annual report card this past month, which is available at retailerreportcard.com. And it's not unlike how, here in New York City, you go to a restaurant and they have a letter grade in front of the restaurant in terms of their cleanliness. They've been rated by, say, a local health department. So just like governments have rated restaurants on their cleanliness, we're rating retailers on their chemical policies or lack thereof. And of course, no one wants to get a letter grade of F or a letter grade of D. And this has been a really powerful way for us to drive companies to improve. Our website, again, retailerreportcard.com. You can go to this website and you can click through and see how these 50 companies, how they're doing when it comes to managing chemicals of high concern like PFAS in their supply chain and their products and packaging. The first year we put out the scorecard in 2016, we evaluated policies of 11 major retailers. And since 2016, we've steadily expanded the scorecard. This year we evaluated the policies and practices of 50 major retailers who represent top retailers across 12 key sectors where chemicals of high concern like PFAS are commonly found. And we include in our evaluations a number of major grocery store chains like Kroger, Albertsons, Ahold Delhaize, Whole Foods, Walmart, as well as top fast food and fast casual chains. Pictured here, you'll see the 8 major fast food and fast casual chains that we evaluated in our most recent assessment. And these are, of course, are household names. None of them have great grades, but you can see that there's a real continuum between those companies at the top, like Panera Bread and Chipotle, and those companies at the bottom, like Burger King and Subway. And by putting out this annual report card, we're aiming to really create a sense of competition between the retailers to drive a race to the top in the retail sector. And if you go to our report, you can see how companies compare with one another across the 13 categories that we look at, which we think represent best-in-class approaches to chemicals management, looking at questions like, does a company have a safer chemicals policy in existence? Do they require their suppliers to test products or packaging to ensure that their suppliers don't contain chemicals of high concern in their assortment? Does the retailer require suppliers to disclose ingredients to the retailer so they can be assessed for safety? Does the company have goals in place to phase out or eliminate chemicals of high concern? Do they have benchmarks that they want their suppliers to meet? How are they ensuring the alternatives are actually safer? Do they have steps that they take to vet the safety of alternatives using tools like the green screen? So by benchmarking companies across these areas, we're really helping to identify the leaders and call out the laggards. If we take a look back, since 2016, by publicly benchmarking these companies and pursuing other activities, we're helping to drive a competitive race to the top in the retail sector. The first year we put out the scorecard back in 2016, we evaluated the policies of 11 major retailers. They didn't score so well back then. The average grade in 2016 was a D+, which is pretty bad. But 5 years later, their grades have improved from a D+ to a B-, which demonstrates that by engaging companies in dialogue, by providing resources, and by publicly scoring them, this is helping to drive continuous improvement in the retail sector. And the issue of PFAS is one of the critical issues that we're benchmarking them on. And we've seen in recent years that as a result of that and a result of other activities, many major retailers are now beginning to work to eliminate PFAS in food packaging as well as other product sectors like textiles, which we just heard a little bit about. So the retail report card has definitely been a great tool that we've deployed to engage companies to address PFAS in their supply chain. If you go to our website at retailreportcard.com, if you go to the leaders and laggards section, you can see this nice snapshot that looks at how companies have been addressing chemicals like PFAS. So the last scorecard we published before now was in 2019. Between 2019 and 2021, 64% of companies that we evaluated have adopted new initiatives to address chemicals like PFAS, flame retardants, bisphenols, and other chemicals of high concern, or have improved their chemical policies in different ways. So if you're interested in understanding how businesses are managing chemicals of high concern, this is a really great resource. And the most recent report card has a lot of interesting information about how companies are addressing PFAS in food packaging and textiles and other important product categories where these chemicals historically have been prevalent. Transitioning a little bit, another way that we've been engaging retailers to drive change has been through citizen science, by commissioning our own independent laboratory testing of products and packaging to identify where PFAS chemicals may be found and releasing that information to the public, to the media, sharing it with investors, sharing the information with retailers. We found that this can be a powerful way to incentivize companies to improve. So we really started digging into the food packaging issue in the summer of 2018, which is when we first sent letters to 75 top grocery store chains and fast food chains, essentially surveying them what were their policies and practices related to PFAS, and if they didn't have any, encouraging them to begin developing corporate chemical policies restricting PFAS. That year, we also had planned to add more food retailers to our scorecard, and we also knew that we were planning on publishing this report investigating PFAS at top grocery store chains. We collected samples from 20 top retail stores in a dozen states across the country. This is a map of the states colored in green where we had collected samples. We sent the samples to Dr. Graham Peasley, a researcher at the University of Notre Dame, and he then analyzed those food samples, the food packaging, for fluorine as a signal to identify whether PFAS chemicals are likely found. As I'm sure many of our listeners know, there are literally thousands and thousands of PFAS chemicals that are out there, somewhere between 5 and 9 or 10,000. Of course, there's no scientific methods that are out there to test for all of them, so we were using the total fluorine method to screen for the likely presence of PFAS, particularly looking at food packaging that is often used for greasy foods. So if we look at food packaging that's used for greasy foods and we're finding elevated levels of fluorine, that's a pretty good sign that PFAS chemicals are likely present. So in this first report we published in 2018, we looked at the food packaging at 5 top grocery store chains. Kroger, Albertsons, and Ahold Delhaize are the top 3 in the US. Some of you may know on the West Coast, Albertsons, they own Safeway. Kroger is all around the country. Ahold Delhaize are big here on the East Coast. They have over 2,000 stores. And then also Whole Foods and Trader Joe's. And interestingly, it was the molded fiber containers that we found were most likely to contain PFAS, particularly at Whole Foods. Even though Whole Foods is, a company that has a, green reputation, and they have a pretty strong sustainability program. Unfortunately, they came out ranking worst in our report. 5 out of 17 samples from Whole Foods had high levels of fluorine suggesting PFAS. We also found it in the packaging at Ahold Delhaize, Albertsons, and Kroger. Surprisingly, none at Trader Joe's. The day the report came out, Whole Foods announced that they would pull the products that we tested from their store shelves that seemed to contain PFAS. And that was because we engaged them in advance. We reached out to them months before a report came out to let them know what we did, what we found, to try to negotiate a commitment from Whole Foods to begin to act. And that was massive because, one, they were the first major grocery store chain to take action, but also they were using over 100 million of these takeout food containers a year that seemed to contain PFAS. So that's a lot of toxic trash that we were talking about. Since then, the company has continued to roll out molded fiber plates and bowls in their prepared food departments in the US and Canada that no longer contain PFAS. And they've also discontinued or reformulated any food service packaging where it was either disclosed or determined where PFAS may have been added, which is great. Some of the other retailers that we tested in that first report, Trader Joe's committed. They said that they were going to now ask their vendors to avoid the use of PFAS in the packaging. And Ahold Delhaize, third biggest grocery store chain here in the US, they launched a chemical policy within a year of that report, and they committed to remove PFAS from their food packaging, as well as other chemicals, including phthalates and bisphenols. We published a follow-up report a couple months later looking at Albertsons, because Albertsons did not pledge action. And in that follow-up investigation, we found 8 out of 10 samples we collected from Albertsons had high levels of fluorine suggesting PFAS treatment, including in cake plates, dental floss, microwavable popcorn bags, and then also takeout clamshells. And the company, to their credit, has now begun reformulating some of these products, like the cake plates, for example. About a year after that first report, our next retailer report card came out in December 2019. November 2019, a third of the companies we evaluated earned failing grades, including Taco Bell, landing themselves in what we call the Toxic Hall of Shame. And 2 months later, Taco Bell announced a new global sustainable packaging commitment, committing to ban PFAS globally by 2025. And that's huge because Taco Bell is one of the biggest fast food chains in the world and the first major fast food chain to announce such a commitment. More recently, last summer of 2020, we published a follow-up report looking at other fast food chains, particularly after Taco Bell moved. So we wanted to compare and contrast the burger chains like Burger King, McDonald's, and Wendy's with healthier food chains like Sweetgreen, Freshii, and Cava. We found high levels of fluorine suggesting PFAS treatment in nearly half of all samples, 14 out of 29. And every single retailer that we collected samples from, we identified products that seemed to contain PFAS from our sampling. Interestingly, the healthier chains fared worse. Every single sample from the healthier food chains contained high levels of fluorine suggesting PFAS. Here are images of the samples from the burger chains, including iconic products like the Big Mac at McDonald's. They sell 1 million of those a day. The Whopper, Burger King sells over 2 million Whoppers a day. We also found elevated levels of fluorine in French fry containers, cookie bag containers. And at the healthier chains, these are the images of the packaging at the healthier chains where we found a likely presence of PFAS in these molded fiber containers. In conjunction and in response to our report, I'm happy to share that Sweetgreen announced that they would ban PFAS out of their compostable bowls by the end of 2020, so within less than a year. And that was a big deal because they were the first fast casual chain to pledge action on these molded fiber containers. 2 weeks after Sweetgreen made that commitment, Chipotle made the same commitment that they would phase PFAS out of their molded fiber bowls by the end of 2020. And more recently, they just disclosed in their new sustainability report that they're also now working to eliminate PFAS from their kids' trays by the end of this year. Two of the other companies in that report we published, Kava and Freshii, they also pledged to phase PFAS out by this coming summer, mid-2021. McDonald's, though, they did not immediately respond to our report. So we launched a campaign calling on McDonald's to lead. We generated tens of thousands of petition signatures to the company. And within less than 6 months of that report coming out and our campaign that was launched, this January, McDonald's announced that they would ban PFAS globally by 2025. And while we're not happy with that timeline, we think they should move more quickly. We think that this is massive. McDonald's is the world's largest fast food chain. They're in over 100 countries over the world, over 38,000 restaurants. So this is a really big deal. We think that this can really transform the marketplace. More recently, and I'm pretty much out of time here, so I'm just going to move quickly through these last slides. Amazon, 7-Eleven, Panera Bread, they've also disclosed new commitments on PFAS.
Hey, Mike,
yep.
Jennifer, you have plenty of time, so you don't need to speed up. Don't worry about it.
Oh, you know what? I thought we had 20 minutes, but yeah, you're right. I have 30 minutes. My bad.
You're good.
I was looking at the timer, and I was like, oh, I'm out of time. It's 20 minutes. I'm like, oh yeah, but there's 30 minutes. Thank you for that. I appreciate that.
Okay.
So yeah, thank you for that. I appreciate that. So stepping back a little bit. So yeah, since McDonald's made their commitment, we've seen other companies step up. Amazon in January of this past year, they announced a new food packaging RSL restricting PFAS in their private brand food packaging. And this, of course, is a big deal. Amazon is the world's largest online retailer. They're expanding their footprint into the grocery arena. And they're rumored to be opening more and more grocery stores. So the fact that they're beginning to restrict PFAS in their private brand food packaging, that could be a sign of more change to come. 7-Eleven, one of the new retailers in our scorecard, they have begun to replace PFAS in some of their food packaging with alternatives. And Panera Bread, they have a food packaging RSL that restricts PFAS, as well as other chemicals, bisphenols and phthalates. And they recently reported to us through our scorecard that they have successfully eliminated PFAS in almost all of their to-go food packaging. These companies are not alone. In advance of our most recent report card that just came out, TJ Maxx, the owners of TJX, as well as other chains, they announced that they're banning PFAS in their corporate office cafeterias where molded fiber containers were being used. So they're looking at their operations, which we think is interesting and certainly a model for other businesses, as well as government agencies that do a lot of procurement. And then Rite Aid, they just recently, also in advance of our report card, they announced that they are expanding their chemical policy, and they disclosed a new food packaging restricted substance list, including a restriction on PFAS for their private brand food packaging. And we think that's interesting because they're the first major pharmacy chain to make such a commitment. As a health-oriented retailer, they're looking at the connections between their role as a health retailer and the products and the packaging that they use in their stores. So if we take a step back and look at all of these commitments that we've seen over the last couple of years since we've started working on this here in the US, we've won commitments from 27 major retailers that have adopted policies to reduce or eliminate PFAS in their stores, in their supply chains. This is massive. This is over 70,000 stores across the US and across the world. And these companies together have over $300 billion in sales. Now, I'm not saying $307 billion in sales of food packaging containing PFAS. This is their total sales, but that's a lot of market power that we're leveraging to drive positive change in the marketplace. However, other companies still need to step up. So this report we published just a couple of months ago in August 2020, 4 out of the 6 companies, McDonald's, Sweetgreen, Cava, and Freshii, have pledged action. And if we take a look at the previous report we did on the grocery store chains, 4 out of 5 of those grocery store chains have taken action, but others still have work to do. Kroger, for example, has yet to act. They're the biggest grocery store chain here in the US. And Burger King, the second biggest burger retailer in the US, has also not acted yet. So once McDonald's announced their commitment this past January, we immediately pivoted, calling on Burger King to meet or beat McDonald's commitment. Surely if McDonald's can do this, if Taco Bell can do this, if Chipotle and Sweetgreen can do this, Burger King can and should as well. And we've launched an online petition on our website at mindthestore.org that folks can visit. I know many of you are in government, but in your spare time, if you'd like to, in the evening hours, visit our website, mindthestore.org. You can sign a petition from your own personal email, joining us, calling on Burger King to lead. Of course, we've also been seeing a lot of progress in the government arena, which has also helped been an important driver of change in the retail sector. Cities like cities like San Francisco and Berkeley have adopted ordinances restricting PFAS in food packaging, which went into effect in 2020. State of Washington was the first state to enact a ban on PFAS, and they just published some new information about how they're going about beginning to implement that, beginning to restrict PFAS in certain items. State of Maine followed suit. Maine has also banned PFAS in food packaging. State of New York also most recently enacted a ban last year, which goes into effect in 2022. So we're seeing a lot of activity in states. And then other states certainly are following suit. If you take a look at this map here on the left, the states pictured in red, those are the states that have so far enacted bans on PFAS in food packaging. And the ones highlighted in yellow are those that that have either already introduced bills banning PFAS or those that are anticipated to introduce legislation during these legislative sessions this year. Another interesting update is I'm sure many of you that work on the waste end are familiar with the Toxics in Packaging Clearinghouse. We have laws all around the country, I think in about 19 states, that restrict things like heavy metals in packaging. So just recently, a couple of months ago, in February, the Toxics in Packaging Clearinghouse announced that they've updated their model Toxics in Packaging policy that now also would restrict PFAS. So we are hoping that states that have adopted this model Toxics in Packaging law, we hope that those states will consider updating their law to align with this new model that the clearinghouse has developed. We also anticipate that federal legislation will be introduced soon. Last year, Rep. Dingell from Michigan introduced legislation that would ban PFAS federally, and we're expecting that that legislation will be reintroduced literally any week now. And we think now with a new Congress, with a new president, we're hopeful that that legislation will move sometime in the year or two ahead. So certainly federal legislation is also in the pipeline. We also are solutions oriented. We've been developing, in addition to our advocacy and reports we've put out, we've also put out guidance for retailers, walking through the steps that companies can take to not only adopt a policy restricting PFAS in food packaging, but how do you go about implementing it? How do you go about testing the packaging? How do you go about addressing disclosure? How do you ensure that substitutes are actually safe? So these resources are available on our website at mindthestore.org. They're free. We've also put out fact sheets that identify examples of companies that can offer safer alternatives for products like plates and bowls and clamshells and takeout boxes, food wraps. So this fact sheet is available on our website at mindthestore.org. For those of you that may be doing procurement in your cities and states, it's a really great resource. And our partners at Toxic Free Future have also published a more extensive database. If you go to toxicfreefuture.org, you can visit this database to identify brands that offer PFAS-free alternatives for different product categories, and it has information about the materials that they use and also whether those are certified compostable by the Biodegradable Products Institute. So with that, I think I am at the end. And I think the closing thing that I want to say is PFAS is really on its way out of food packaging, especially here in the US, but also globally. Action is pending in Europe. And we think that for those of you that are working in cities and states around the country, a lot more can be done to work with these other states to enact policies and programs to restrict these chemicals in food packaging, especially given the fact that the market is moving, safer, cost-effective alternatives are available, and it's the right thing to do to safeguard public health and the environment to reduce our exposure to these forever chemicals. So thank you so much, and if anyone is interested in getting in touch, here's my contact information, and we'll look forward to Q&A.
Excellent, thank you so much. And we do have a lot. See. Well, first, I'm going to just mention that Mike mentioned the Toxics in Packaging Clearinghouse. And there is a webinar next week on the 28th with more information about that model legislation and about what the Toxics in Packaging Clearinghouse is. So I will send information, a link about that webinar out to everybody when the slides are posted, and I send that email out. So yes, the slides will be posted for your future reference. So I guess I'm wondering about, somebody asked, what's the specific PFAS that's most commonly used in food packaging? Do you know?
Yeah, there's a number of them that are approved for use by FDA. They have long, complicated names that I can't spell out right now. So there are a number of chemicals that have been approved by FDA. There's only one chemical manufacturer here in the US that still makes these chemicals for food packaging. The rest of it is imported from overseas, particularly in Europe. The company that makes the chemicals is a company by the name of Daikin. Now, one interesting development is that the FDA has recently reached, this was announced last summer, they reached a voluntary agreement with Daikin and some of the other companies that are that have authorization to use PFAS in food packaging here in the US. They reached a voluntary agreement to phase some of the so-called, well, not so-called, but some of the short chain PFAS chemicals out. However, companies may still use other PFAS chemicals for use in food packaging. And one of the things that I think is really interesting about that is the reason that they reached this agreement with industry is because FDA scientists were studying some of the replacement chemicals. And when they started studying them, they realized that in a number of cases, the replacement chemicals that companies like Chemours and Daikin and others were arguing were safe, they learned were just as toxic in certain ways and also much more bioaccumulative than industry was arguing. So, and this is something that we've seen time and time again with this issue. You know, the industry has said for years, oh, you know, we're going to phase out the long chain chemicals, but the short chain ones are safe. And the more that independent scientists in academia and government have studied these replacement chemicals, we've learned that in a number of cases, they may be just as toxic in some cases and even more toxic in other cases, but generally just as persistent in the environment. And that's one of the reasons why we're really concerned about their use in food packaging, because again, the packaging is used once, the chemicals can then last forever in the environment. And that's why we think it's really critical for policymakers and businesses to take a class-based approach to avoid regrettable substitution, because we're going to be, you know, if we work on these chemicals one chemical at a time, something like 4,000 to 9,000 out there, we're going to be working on this for hundreds or thousands of years. We really need to restrict them as a class, especially given their widespread persistence and mobility in the environment. But to get at your question more specifically, I would encourage readers to take a look at the reports we've published, the Takeout Toxics report and the Packaged and Pollution reports. Those are available on our website at mindthestore.org, and we have more information in there about which specific PFAS chemicals are permitted for use right now. But again, we think it's critical for policymakers and businesses to take a class-based approach to mitigate environmental and public health risks.
Yes, so that gets at some other bunch of different trains of thought here on the questions. But one is about regrettable substitution. Do you know if they're taking the fluorinated chemicals out of this molded containers and the coating on paper, you know, what they're substituting them with, and you know, yeah. Is that okay?
Yeah, that's a really good question. I'll just go back to my slides here. This fact sheet has some useful information about some of the alternative technologies and materials that are out there. You know, in some cases, some companies are just using straight up paper that is uncoated. In other cases, some companies are using paper with clay coatings. In other cases, companies are using paper with bio-based coatings. In some cases, some companies are using straight up bioplastics like PLA. Now, some companies have not been as transparent about the substitutes that they've used. And that's something that we think is a challenge, and I think that's an area where government really needs to step in and help assess and vet the safety of alternatives, so we're not playing the whack-a-mole game. But this fact sheet we put out has some information about alternatives. This database we've published also has information about alternatives. The state of Washington has also recently just published a report as part of their regulatory work to implement the ban on PFAS in food packaging in the state of Washington. They have published this report that has some useful information about the alternatives. You know, if you take a look at the alternatives, for example, that Sweetgreen and Chipotle use, they've moved from they moved to other molded fiber containers that contain bio-based formulations that the manufacturer, which is a company by the name of Footprint, they argue is safe. They say is a bio-based chemical alternative that they claim does not contain any harmful ingredients, but they have not fully disclosed their formulation. So I think when regulators and when businesses are, you know, transitioning to alternatives, they really need to work with their suppliers to vet the safety of alternatives. And there are tools that are out there like the green screen that can help companies vet the safety of alternatives. The green screen is a hazard-based methodology that can be used to evaluate the safety of alternatives so that policymakers or businesses are making more informed decisions about substitution. I know that the Toxic Use Reduction Institute and the Interstate Chemicals Clearinghouse have a lot of great resources that are out there that can that provide models for how does one go about vetting the safety of alternatives when making a decision about substitution.
Great. So there's several people wanting to know about your sort of going back in time to the trust but verify. A lot of companies have made these promises, but are you going out and actually verifying through follow-up testing that these changes have been made?
We haven't yet on the PFAS front, but we definitely plan to do that in the years ahead. I mean, just to give an example of that, this is not related to PFAS, but a few years ago, we were working on phthalates in vinyl flooring. This was earlier in our campaign. I think this was around 2014 or 2015. We published a report investigating orthophthalates in vinyl flooring. We found that most major retailers like Lumber Liquidators and Home Depot and Lowe's were selling vinyl flooring that contained very high levels of phthalates. And we were concerned because phthalates can migrate out of the air, that they can migrate out, get into indoor air, get into household dust, posing risks to building occupants, consumers, pregnant women, young children. And through the engagement with the retailers in the campaign, we won commitments from most major home improvement chains, including Home Depot, Lowe's, Lumber Liquidators, Floor & Decor, and others to ban phthalates in vinyl flooring. Most of those companies had adopted commitments to ban phthalates in flooring by the end of 2015. About a year and a half ago, we went back and we collected samples. We did spot checking for the retailer, from some of the biggest retailers that we had won commitments from, like Home Depot, Lowe's, and Lumber Liquidators. And the good news is all the samples we conducted came back clean. They did not contain measurable levels of orthophthalates. But that's all to say also at the same time why we not only need voluntary commitments from companies to do the right thing. I mean, that's great. That's really important. But that's also why we need government policy, especially at the federal level, right? You know, states that are acting, that's great. And that coupled with voluntary commitments from companies is also important. But that's also why we need federal legislation to restrict these chemicals. Voluntary corporate commitments is not enough. I should also say that that's also why we put out our annual scorecard to benchmark companies to continue that they're following through on the commitments that they have made. So that's kind of another element of our work. So in addition to the product testing that we plan to eventually do, we use our retail report card to hold companies accountable to ensure that they're following through on the commitments that they've made. But yeah, overall, I totally agree with the question because it's very important.
Okay, then there's some other questions going down another track is about the measuring total fluorine, and that I just note for people is fluorine with an F as in Frank, not chlorine with a C as in Chuck. It's fluorine with an F, and about the total fluorine, and would you have fluorine with an F in these packaging and these molded products without them being PFAS, or is it really, you know, what's the equivalency there, you know?
That's a really good question. You know, it's not 100% bulletproof, right? I mean, that's why if you, I was trying to be careful about this. When I talk about this, I'll usually say that we found elevated levels of fluorine that suggests or indicates PFAS treatment. You know, we do see in some of our investigations lower levels of fluorine, which probably suggests that either there's a contamination problem in the supply chain because of, you know, widespread presence of PFAS in the environment. But the levels we're seeing of fluorine are pretty high, and they are found pretty high in materials where historically we know the chemicals have been used. And we know the chemicals have been used because companies like Daikin and food packaging brands, they promote and they advertise their use in these types of products. And at the same time, we're also finding them in products where greasier foods are being used, like the small French fries at McDonald's, or the Big Mac at McDonald's, or the Whopper at Burger King. So when we communicate with businesses, we often will say that, you know, you need to communicate with your suppliers to understand what's going on. Is it PFAS that's being added, or is it something else? But I would say from our communications with the businesses that we've engaged over the last few years, 9 times out of 10, it is intentionally being added to achieve grease or water, mostly grease resistance for these applications. It's possible that maybe there could be something else going on, but for all the reasons I mentioned, 9 times out of 10, it is intentionally being added in these applications.
Okay, and just as a bit of a follow-up, some of the state folks are wondering about, like, what's the level of concern with the fluorine? Is there like can you say, you know, 100 ppm and you worry about it, and less than that, probably not that concerning, or is any level, or you have a number that you could throw out there?
Yeah, we talk about, you know, the uncertainty about that in our in the reports we've put out. In the most recent report we put out, we aligned with the level that the biodegradable products, I think it's Biodegradable Products Institute, have set. For some of you probably familiar, the BPI, who they have a third-party standard for biodegradable packaging, and they, like a year or so ago, they set a restriction on PFAS in biodegradable packaging, and they set a standard of 100 parts per million. So in our investigation that we put out this last summer, we used 100 parts per million as a screening threshold. Now that's not to say that levels of PFAS below 100 parts per million, because we did see examples of packaging that were, you know, below 100 parts per million, but above the limit of detection, which I think was around 10 parts per million, if I remember correctly. We think that that is probably mostly PFAS being present as a contaminant, you know, because of, you know, widespread contamination in the environment, you know, especially in water, and also in the pulp industry. You know, if you think about some of these cases, companies are using recycled papers that may have PFAS in the recycled paper, and it's being present as a contaminant. But, you know, from talking with packaging companies and packaging engineers, the levels of fluorine that we're seeing are relatively high. And from talking with leaders in the packaging industry, they've told us that when we're seeing the levels of fluorine that high, they expect and they believe that it's being added intentionally to achieve the grease or water resistance. You need PFAS in there at levels around that to achieve the grease and water resistance. So that's why we've been using that level. And in some cases, the levels we're finding much higher, thousands of ppm in the case of the molded fiber containers. And if you take a look at our report, you can actually download the data and see the levels that we found. We've made all of that publicly available I believe for all 3 reports we've published, all 3 of the product testing investigations. And we talk more about this methodology in the report. So if anyone is interested in kind of diving into the methodology, you can take a look at that. And I should mention that the lab that we used for this most recent investigation was Galbraith. And I know that there are other third-party labs that are out there that can do this sort of analysis, and it's not too expensive to do this.
Okay, great. Well, so we are at 3 o'clock, but there's 2 last sort of trains of questions that I think are interesting and good. So folks can hang on if you want, but I'm going to keep going and ask them, and hopefully Mike and Liz can stay on for a little bit longer. So the slides will be posted. Thank you, everybody that joined today. But here's another question. It says, have you done any testing, or are you aware of it, about the food that has been in the packaging? Are you aware of it? Studies about the transfer of the PFAS from the packaging into the food itself?
Yeah, if you take a look at the peer-reviewed literature, there have been studies that are out there that have documented PFAS migrating out of packaging into the food, and I believe we cite some of those studies in our report. We didn't test the food itself in these investigations because that question has already been answered. We know that it can migrate into the food. So given that, we decided to focus on the packaging itself, because we think that if we're going to address this issue, we really need to draw attention to the source, the packaging itself, which is a key reason why it's getting into the food. I mean, it can also get into the food further up the supply chain. We know that there have, of course, been farms, like in Maine, where we've seen contamination on farms. So that's not to say that it can't get into the food from other sources. It clearly can. But we focus on the packaging because we think that's a strategic point of intervention to drive positive change. Yes,
it certainly is. So the last vein of questioning that will go up is you've been engaging with these larger companies. A lot of people are typing in, have you looked at in their favorite sort of smaller chains, or the delivery services that give you the prepackaged sort of meals the meal kits. But also I'm thinking about the corner guy around me who's trying to do the right thing. They think, oh, it's compostable, this is great, it's better than styrofoam. So about the awareness across the whole sector, including smaller folks and people that, a lot of these smaller restaurants and things, the proprietors are not big English speakers, and just, how do we get at and engage and raise awareness more widely? Because Liz, not everything in this political climate is going to enact. So I don't know, maybe the federal government will, but with that, in the absence of that, what can we do?
So this is Liz. I just want to bring up the project that you folks at NUMOA and at Clean Production Action have been working on, the Transparency Project, because I think a lot of the issues that our manufacturers have is that information doesn't come through the supply chain. And so if there is better transparency, then the guy at the corner store might be able to find out what's the grease-proof treatment is on his paper. Otherwise, even no matter how good his English is, he's not going to know. He's not going to be able to find out.
Right.
Yeah. I think it's a good question, and that's also why we put these guides out to try to walk companies through the steps of going about enacting a policy. I mean, clearly it's, you know, for Jane Doe, it's going to be more challenging, I think. But also, I think, in hope that, you know, the fact sheets we put out that can help companies identify examples of suppliers that do offer alternatives. And it's also our hope that, I think the final two things I would say is that as some of the big retailers move, hopefully that'll bring down the costs for the little guy to be able to, you know, identify and purchase alternatives. And then secondly, that's also why we need government policy reform. You know, we need to lift up all boats, not just the big corporations, and that's why we need policy reform at the local and the state and the federal level so that everyone is protected, not just those that, you know, eat or, you know, shop at, you know, Sweet Green or Taco Bell or wherever.
How about, have you been engaging with the FDA on this?
Yes, but progress is slow, unfortunately, and that's why we really need Congress to step in. I know that some other NGOs like EDF and NRDC have been working hard to reform the FDA for many years, but if we thought the, you know, EPA's work on TSCA was bad over the last 30 years, FDA is sadly even worse in many respects. Because FDA actually has more authority. They've had more authority for years. They just haven't used it until recently with some of these voluntary commitments. But that's why we think we really need congressional action. And we're excited that Rep. Dingell will be introducing legislation soon. And you know, if folks are so motivated, you know, one thing you can do is, you know, on a personal level, contact members of Congress to encourage them to support Dingell's bill when it's introduced.
Excellent. Well, thank you so much, both Liz and Mike. Both excellent presentations and great work that you're all doing. So thank you so much. But we are, according to my clock, 7 minutes past our end time. So I think we'll shut it down now. So thank you again. This was great. Thanks to everybody that hung in there. And I will be sending out an email to everybody that participated when the slides posted on the NMOA website. And I'll also share information about the webinar next week about the Toxics and Packaging Clearinghouse and their model legislation on PFAS. And just enjoy the rest of your day. Thank you so much, everybody. Thanks again.
Jennifer.
Thanks again to Liz and Mike.
Thank you. Thanks for the opportunity.
Bye, everybody.